Today I am going to take the topic of problems regarding Fresnel diffraction. So throughout the class of Anaga and Alexa, we already discussed about Fresnel diffraction. So just recall that. So we can illustrate it like, consider this as a point source and this as a slit. So the light from this point source gets diffracted into this slit, and again it gets diffract into a same point, and this is the screen. So the image is formed here. So this is considered as a Fresnel diffraction. So do you remember the Fresnel diffraction? Advaita, you already thought about Fresnel diffraction, right? So can you mention some of the difference between the Fresnel diffraction and the Fresnel diffraction? Anyone?
In Fresnel diffraction, the light source is from infinity, and in Fresnel diffraction, it is not from infinity. And in order to get the diffraction pattern in that situations, we have to use convex lenses for Fresnel diffraction, and this one is in Fresnel diffraction.
Very good. The main difference is, as she told, in Fresnel diffraction, where the source and screen are at finite distance. It is in finite distance. But in Fresnel diffraction, it is at infinite distance. And in Fresnel we use lenses, but in this diffraction we didn't use any kind of lenses. So the wavefront is spherical or cylindrical. Is it clear? So let's move to the question parts. So let's start with a simple question. Right. First question is, light of wavelength lambda equal to 520 nanometer, and the observation point is at distance b equal to 1.25 meter. Find the radius of first Fresnel zone. Get it? So we know that the general equation for radius is Rn equal to root of n lambda t. Here we have to find the first radius of first Fresnel zone, right? So the n is equal to 1. So it will be root of 520. That is the wavelength 520 into 10 raised to minus 9, since it is nanometer, and the distance is equal to 125 meter. So the answer will be either 8.06 into 10 raised to minus 4 meter. Is it clear? So can we move to the second question? Find the radii of the first three transparent zones of zone plate whose first focal length is equal to 1 meter. F is equal to 1 meter, and lambda is equal to 5,893 angstrom. This question is from the textbook. So we have to find the radius. The radius of the first transparent zone. First three transparent zones. We know that R is equal to lambda n lambda d. So for the first n lambda f. So for the first zone, it will be R1 equal to root of It is Aneena Armstrong, right? So it will be 5.83893 into 10 raised to minus 7. So substituting it in this equation, 1 into 5.893 into 10 raised to minus 7 into 1. That is 0.768, approximately equal to 0.77 millimeter. And for the second zone, it will be substituting n equal to 2. 2 into lambda 5.839 into 10 raised to minus 7 into 1. That is 1.085 millimeter, approximately equal to 1.09. And at last we have to find the radius of the third zone. That is equal to what? Root 3 of first Fresnel zone, right? So it will be 1.329, which is equal to 1.33 millimeter. Is it clear? So we can move to the third question. And in Alansa's class, we discussed about the radius of the first Fresnel zone, half period zone, right? So the radius is equal to Alansa equation, root lambda AB equal by A plus B. So just remember this equation and we can use it in the next question. Next question is, a point source is placed at A equal to 80 centimeter in front of, and the observation point is at B equal to 120 centimeter behind it, and the wavelength is given by lambda equal to 500 nanometer. Find the radius of the Fresnel half period zone. So we can directly substitute these things into this equation, and the equation it will be root of lambda equal to 500 into 10 raised to 9 into A equal to 80. Where A is the distance from source to diffracting aperture. So 18 into B. B is the distance from diffracting aperture to the screen. So it will be 120 by A plus B. 80 plus 120. So it will be 4.90 into 10 raised to minus 4 meter. So the next question is, this is from the previous IIT JAM question paper. The question is, in a Fresnel diffraction experiment, A is equal to B. Initially, the distances are A and B, and again it is double. So how does the radius of the first Fresnel zone change? So we know that the equation of radius is equal to root of lambda AB by A plus B. So initially it will be like this only. So lambda AB equal to lambda AB by A plus B. So after they double, the A dash equal to A will be doubled. So 2A and B dash is equal to 2B. So substituting this value into this general equation. So R final will be root of lambda into 2A into 2B plus A plus B. 2A plus 2B. Which will be 4 lambda AB by 2 into A plus B. So cancelling this and it has 2. So it will be root 2AB by A plus B. So it will be 2 root 2 into root AB lambda by A plus B. So this equation is the equation for R initial. So the final radius is equal to root 2 into R initial. Is it clear? So we can move to the last question. For plane wave Fresnel diffraction, show that the area of each half Phillips zone is same. So we have to find show that the area is same. So the equation of area is equal to pi r square, right? And we have to prove all the conditions. So we can substitute it as pi into Rn square minus Rn minus 1 square. So Rn square is what? N lambda d from this equation, right? R equal to root lambda d. And R n minus 1 square is equal to n minus 1 lambda t. So substituting these values into this equation, it will be pi into n lambda d minus n minus 1 lambda d. After cancelling, we can conclude that an is equal to pi lambda d. So we covered almost all the topics covered in Fresnel diffraction, and I can post some of the questions in the group, and you can do it yourself. So hope you clear. Thank you.